Okay, so we are going to now start with double angle formula. So double angle identities or properties, whatever you want to call it, properties, continue. Okay, so yes, there will be class on Sunday. Monthly test is from 10 o'clock, right? Our class will be from 8 to 9:30. Okay, so let's get started. So 2 tan inverse x formula. 2 tan inverse x formula. Now we need to take this formula in terms of cos inverse. Now this time, I would ask you to do all the hard work. So if it is cos inverse something, what is this something going to be? And for what values of x? Okay, let's answer this. And are there any more formulas to it? That means, are there any subparts to these properties? Let's try to figure out. So who will tell me what is this question mark and what is this double question mark? Yeah. Very good, Ritvik. Are there any more formulas or this is the only formula? And what is the interval of x? What is the interval of x? Okay, now let's say I'm a person who normally forgets things. If I have to solve this question, how will I solve it? I'm just going to use my property number 2, nothing else. There's nothing that I'm going to carry forward in this formula, other than property number 2. So let's say I call this angle as an angle A. Okay. Now, one thing that you would all notice here that your A basically lies between minus pi by 2 to pi by 2. So 2A will lie between minus pi to pi. Okay. 2A lies between minus pi to pi. Correct? Now, please pay attention. The first thing is I want to know this question mark. So basically, if you take this cos inverse to the other side, that means if you take cos on both the sides, you are basically getting cos 2a on the left side, isn't it? So if this is a, this is cos of 2a. Cos of 2a, I need to write in terms of x. X is nothing but tan of a. So how do you write cos 2a in terms of tan a? Simple. 1 minus tan square a by 1 plus tan square a. Right? And this is nothing but 1 minus x square by 1 plus x square. Okay. All of you please pay attention. Now, this is your cos of 2a. And what are you doing? You want 2a on this side. So you're taking cos inverse on both the sides. So if you're taking cos inverse on both the sides and you want 2a to be left off. So when I take cos inverse on both the sides, I'm taking cos inverse on both the sides. And I want 2a to be left off. That means what? That means 2a should have been in the principal value branch of cos. Principal value branch for cos is 0 to pi. Correct? That means a should have been left between 0 to pi by 2. Right? And a is what? A is tan inverse x. Correct? So tan inverse x should be from 0 to pi by 2. Of course, pi by 2 it cannot take. So pi by 2 you have to exclude from there. Correct? So x will be from 0 to infinity. So this formula is going to work as this. This question mark becomes 1 minus x square by 1 plus x square. And this double question mark becomes 0 to infinity. Okay? 0 to infinity. Now, please pay attention. Everybody, please pay attention. The second part of the formula I'm going to get right from here itself. Okay? Now, you have already taken care of this interval 0 to pi, and your 2a was supposed to be from minus pi to pi, correct? Yes or no? So basically, let me write it like round bracket only, because ultimately we have to use round bracket only. So minus pi to pi, from there you have already used 0 to pi. So what is left? Pi to 2 pi. So this is an interval where the next interval is an interval where your 2a will lie between pi to 2 pi. Sorry, 0 to pi. No, sorry, where is it? Minus pi to 0. Yeah, I'm so sorry. Minus pi to 0. Minus pi to 0. Correct? Yes or no? Because 0 to pi you have already taken care. And this entire thing 2a will basically go from minus pi to pi. So, bacha kya? What is left? Minus pi to 0. Correct? So, if 2a is between minus pi to 0, that means your a is between minus pi by 2 to 0, which means your tan inverse x is between minus pi by 2 to 0. That means x is between minus infinity to 0. Correct? Yes, 0 may be included at this place. No problem with that. So I'll include it here. It doesn't make any difference to our answer. We'll check it out also. So I will include my 0 in this interval. Okay. So the interval here at least is known to me pretty quickly. That interval is minus infinity to 0. This thing. Okay. Now what will be the answer? What will be the answer? See, the answer is very simple. There are two ways to figure it out. One is if you want your 2a to be between 0 to pi, right? And cos inverse x is, minus pi to 0, and cos inverse is from 0 to pi. So what is the relation that I should have between them? So you are now looking at minus pi to 0 for 2 tan inverse x interval, and cos inverse is known to be from 0 to pi. So what should come over here? What should come over here? Negative of this answer, isn't it? Negative of this answer should come. Exactly, correct. Another way to look at it is, see, at this stage when you are aware that your 2a is between minus pi to 0, when 2a is between minus pi to 0, cos inverse cos theta will give you what? Negative theta, right? I hope everybody recalls the graph of this cos inverse cos theta versus theta. So if you're looking at minus pi to 0, the answer should come out to be minus 2a, right? So if minus 2a is this, it is very evident that 2a will be negative of cos inverse 1 minus x square by 1 plus x square. So there is nothing to remember in this. If you are able to figure one of them out, along with the intervals, everything will come out. This formula is not a prerequisite. This formula is an outcome of logic. Okay. Second thing that you can observe here is that this interval is exactly negative of this interval. Correct? This interval is exactly negative of this interval. So in this entire top formula, change your x with a minus x. That will also help you to get to the same figure. So many methods to reach the answer, that I'm discussing with you, that you don't have to remember it at all. Okay. So along with the interval, along with result, everything will come out. Now we will try this strategy on our subsequent properties so that you get a chance to exercise whatever I have discussed on the subsequent property. Meanwhile, before I move on, I would like to ask you a question. What do you think is the graph of cos inverse 1 minus x square by 1 plus x square with respect to x? So the next thing that we are going to draw, let us draw here. Sketch the graph of sketch the graph of cos inverse 1 minus x square by 1 plus x square. Okay. Would you like to try it, or should I directly do it? Okay, I would request everybody to try it. You can use this particular formula. I'm so sorry. You can use this particular formula. Make cos inverse 1 minus x square by 1 plus x square the subject of the formula. Just tell me done once you're done. There's no need to, of course you can't draw the graph and tell me. Just say done once you're done with the graphing it. See, it's very important. This exercise which I'm doing with you is very important because graph solves a lot of things pretty quickly. I think last class we saw one of the questions which was very easily solved when we use the graph of sine inverse of 2x by 1 plus x squared. So I'll also do along with you. So basically redefining this function. So cos inverse of 1 minus x square by 1 plus x square can be redefined as 2 tan inverse x when x is positive and negative 2 tan inverse x when x is negative. Okay. Now, ideally, if you draw one part, you don't have to worry about the other part because what kind of function is this? Even hai ya odd hai? Jaldi batao. What is it? Even or odd? Even or odd? Even or odd? Even, right? So if you draw the part which is on the positive side of the x-axis, you can easily reflect that part about the y-axis to get the negative side of the x-axis. Okay. So 2 tan inverse x graph we have to draw for positive values of x. So let me just draw. Okay, so 2 tan inverse x graph. All of you please pay attention. So 2 tan inverse x graph for positive value of x will go like this. Okay. In this, we only have to draw that part which is in the positive x-axis. That means this part will go off. We don't need this part. Okay. So once you have drawn this part, as we already discussed, it's an even function. So the next part will be like this. Almost like a, sorry for this small glitch over here. There you go. Very difficult to, yeah. So it's basically like a bird flying. Okay. So this is the graph of, cos inverse 1 minus x square by 1 plus x square. Now let's quickly comment on the differentiability of the graph. I know I have not done with you officially, but if you see at zero, this function will not be differentiable because there is a, cusp getting formed over here. And you can easily find out that if you differentiate the left hand and the right hand part of the function at 0, one of them will give you the answer as 2, other one will give you the answer as minus 2. Okay, so if you make a tangent over here like this, it will have a slope of 2, this will have a slope of minus 2. Okay, we will discuss about differentiability under the continuity differentiability chapter in lot of details, so don't worry about it. So this is the graph of cos inverse 1 minus x square by 1 plus x square. Okay. Now, a few questions that may come something like this. Let's say somebody asks you, find the number of solutions. Find the number of solutions. Find the number of solutions of this equation. Let's say cos inverse 1 minus x square by 1 plus x square is equal to, let's say, 3. Okay. Let's say how many solutions exist, right? Now, of course, you can solve it in the regular way, but if you know the graph, you can easily figure out that the person is asking you how many places is this graph intersected by this line. Y is equal to 3. So 2 places, 2 solutions, over. Game is over. Okay. So all such kind of questions can be, especially related to the number of solutions, etc., can be easily be addressed. Okay. Is it fine? Any questions? Any concerns? Sir, how did these functions become non-invertible? Are you asking how is this function invertible? Aditya, I didn't get your question. Oh, how are they not one-to-one? So why should they be one-to-one? Just because there's a cos inverse sitting? Huh? Just because a cos inverse is there, there's an inverse of a function. No, doesn't mean like that. Okay, this function is not invertible. This function is not invertible. Okay, so please note, cos x inverse is cos inverse x. That is fine. But it doesn't mean wherever there's a cos inverse x, you will try to find an inverse for it. This is a non-invertible function. Why should it be? Why should every function be invertible? Just because we are dealing it in inverse trigonometry, only the basic ones that we have seen in our standard inverse trig functions, those are invertible. These are all the derived ones. They need not be invertible. Okay. All right. So now we are into property number. Property number. Who will tell me which property number? I lost the count. Sorry. This is 10th or this is 11th? Anusha, it's 10th. Okay, thanks. Okay. Now I'm going to basically talk about 2 sine inverse x in terms of sine inverse. So what we did in the previous property was we learned 2 tan inverse x in terms of tan inverse, sine inverse, cos inverse. Now we have to do 2 sine inverse x. I hope I have not done this part. Have I done this in terms of sine inverse? No, right? Okay. Now let's try to figure this out. Now I will not tell you anything. You are equipped with all the tools that I could share with you to figure this out, right? So now you become my teacher. Okay. Tell me, how do I get these answers and how do I get this interval? So what is this question mark? What is this question mark? And are there any subsequent formula associated with it? If yes, tell me how to figure it out. You become my teacher. Anybody wants to unmute and say, sir, this is this because of so and so reason. Yes, please go ahead and derive it. Right? It will not serve any purpose if I do everything. Right? Ultimately, you are writing the exam. You have to sit for all those exams. So it's better it comes from your side. And I'll be more than happy if you tell me what to do. Yeah, Havish, you want to speak up or something, or you want to just try on your notebook?
Yes, sir. I mean, I would love to speak up, sir.
Yeah, please do so. Yeah.
So, in school, I guess I remember doing this one. Sine inverse would be 2x to the root 1 minus x squared.
Okay. I'll come to the reason for the same. And what is the interval for which it is valid?
I suppose it would be between -1 by root 2 and plus 1 by root 2.
Okay. And do you want to include both of them in your answer or exclude?
Include, sir.
Include them. Okay, very good. What now? Okay. Do you want to share any other subsequent sub-properties under this, or?
No, sir. I don't remember anything of that sort.
You don't have to remember. That's the point. Right? Yeah, it will come from logic. It will come from logic. Now, see, many of you. Oh, thank you, Avish. Thank you for contributing to the first part of the formula. So, see. Okay, let me let me allow people to do it because some of you would be working it out. I don't want to disturb you guys, so take your time. We will discuss in few minutes. Gaurav, the first message I saw of yours is none actually. This is the very first message I'm seeing from your side. Sir, now can you see my messages? Earlier there was no message on my chat box from your side. No. Unfortunately, those messages did not reach me, but now I can definitely see your message. Okay. I hope you have not missed out any important part. So prior to this, we were doing the formula of 2 tan inverse x in terms of cos inverse. Now we have jumped to 2 sin inverse x in terms of sin inverse. Okay, so Kshitij claims that there will be 2 more intervals. Okay. And would you like to tell the formula first or would you like to tell the interval first? Better to tell the interval first. Kshitij, would you like to tell the interval? No? Anybody who would like to contribute to what are the other intervals possible? So some people are
Hello.
claiming that there are 2 more intervals possible. Okay. Yes.
Hi, sir. Can you hear me?
Yes, Kshitij, please tell me.
I think one of the intervals is 1 by root 2 to 1,
1
both
by root
included.
2 to 1, both included. Cool.
And it's a pi minus sine inverse 2x.
Okay, so you say it's pi minus sine inverse of 2x under root 1 minus x square. Okay. Next
And
one.
I think the other one second, I'm trying to. I think the other one is pi plus, or I can't figure out the exact correct one.
Okay.
It's
Can you
probably
please?
minus pi minus sine inverse.
Okay. And what interval of x?
The remaining 1 by minus 1 by root 2 to 1. To 1.
Minus 1 to minus 1 by root 2. Now see, the first thing that I would do, let's say if I am starting this from scratch, okay, and I don't know, I don't remember any formula. I mean, normally also if I have not practiced it, I will not remember things. That is true for everybody, not only with me, true for everybody. Now I know that I'm dealing with twice of sine inverse x. Okay, so if I call this as an angle A, then 2a will be a value between minus pi to pi. That everybody knows. Correct? Because sine inverse x, which is your a, has to be between minus pi by 2 to pi by 2. So twice of that will be from minus pi to pi. Okay. No doubt about it. Now, the first interval that you have got is when you have broken that. Now I have to break this interval. Now see, this is the task I have to perform. Isko todna hai. I need to cut it out. Okay, I have to start cutting this out. So the first interval that you have got is actually when you have cut this guy out between minus pi by 2 to pi by 2. If you don't trust me, let me show you a few more steps here. Because your a lies between minus pi by 2 to pi by 2, your a basically lied between minus pi by 4 to pi by 4. And a was sine inverse x. This guy was sine inverse x. So x will be what? X will be take sine of these two angles. That is minus 1 by root 2, 1 by root 2. So minus 1 by root 2 to 1 by root 2 becomes your very first interval, which Havish also mentioned a few minutes earlier, right? So now that interval is gone. So now from this interval, minus pi by 2 to pi by 2 is gone. What is left? On either side of minus pi by 2 to pi by 2, you will be left with these intervals. One will be pi by 2 to pi, I mean ahead of pi by 2, and the other will be below minus pi by 2. So it will be minus pi to minus pi by 2. Okay. Now this too will help me to get these figures that you see, which Kshitij has just now told. How? Again, same procedure. It's not a rocket science. Same procedure. So if your 2a is between this, that means your a is between, a is between pi by 4 to pi by 2. A is what? A in your mind is sine inverse x. So what is x? Take sine of these two angles. So sine of pi by 4 is 1 by root 2. Sine of pi by 2 is 1. So that is what Kshitij mentioned over here. Okay. I will come to the result in some time. Don't worry. This result I will tell you in some time. But this basically helps you to figure out how many intervals are possible. And how do you decide the size of the interval? Many people would have this question. Sir, आपको कैसे पता कि pi by 2 से pi तक ही जाना है, pi by 2 से 3 pi by 4 तक नहीं जाना है? How do you know that? See, you can go to any interval which is in the pi interval. See, what was the interval of sine inverse? Minus pi by 2 to pi by 2. So the gap is of pi. So within pi, nothing will change. Don't worry about it. Within pi, nothing will change. And it is true for all the functions also. For cos also, if you see 0 to pi, there is one output. Pi to 2 pi, there is another output. So in a gap of pi, nothing is going to change. So within a pi gap, you can take any interval you want. So maximum from what I can take is from pi by 2 to pi itself, because this gap is just a pi by 2 gap. So that's fine. I don't have to break it further. Now this tells you the second interval. Similarly, third one, you know that your a will be between minus pi by 2 to minus pi by 4. So sine inverse x is that. So x will be from minus 1 to minus 1 to minus 1 by root 2. So this is how you came to know that there will be 3 parts to the formula. Okay. Now, how do you get the result? See, the result is also very simple. Ultimately, in the very first step, you have actually written sine inverse of 2a, sine of 2a as 2x under root of 1 minus x square. That's how this figure actually came out, right? And you want to make 2a the subject of the formula. So every time you have to take sine inverse on both the sides. And depending upon this, your output is changing. So when your 2a is between pi by 2 to pi, let me recall the graph. From pi by 2 to pi, you are basically following this part of the line. This part of the line equation is y is equal to pi minus x. So this answer will be pi minus 2a is equal to sine inverse this. Right? If you make 2a the subject of the formula, it becomes pi minus sine inverse 2x under root 1 minus x square. That's what Kshitij told over here. All of you can see here. Got it? Okay. Everything is basically coming from this step only. The left-hand side answer is varying depending upon your interval of 2a. Okay. Now for the third sub part, if I want to know the formula, I'll erase this off. And now I will focus on this guy. I'll focus on minus pi to minus pi by 2 area. Minus pi to minus pi by 2 area will be this area. Minus pi by 2 to minus pi will be this area. This area. This equation is very, very easy to figure out. It's nothing but minus pi minus x. It's a negatively sloped line and cutting down at minus pi. So this answer will be minus pi minus 2a is equal to sine inverse of 2x under root 1 minus x square. Now make 2a the subject of the formula. So 2a will become minus pi minus sine inverse this. Okay. So there you go. The third formula comes from there. One more thing, one more observation you can have is the third formula interval is exactly negative of the second and the third intervals are exactly negative in sign. So you may use the second formula also to come to the third one just by replacing x with a minus x. So I'm just telling you all these tricks to minimize your memorization load. Okay, it's very easy for me to dump this formula in front of you and say solve questions, but that is not going to help any purpose. So I hope the agenda of how it works is clear. Okay, we'll have more opportunities coming up our way. Don't worry. So you'll get more chances to utilize whatever we have discussed so far. How do you go from 2 to 3 directly? Change your x with a minus x. Chalo, I will do that also. So let's do as an exercise. So I know the second formula, let's say. I know the second part of the formula. Second part of the formula is known. What is the formula? I'll write again. 2 sine inverse x was sine inverse of 2x under root 1 minus x square. And this was true for x lying between, I'm so sorry, pi minus. It was true for 1 by root 2 to 1, correct? Now what I will do, I'll replace my x with minus x. So the left side will become, correct me if I'm wrong, negative 2 sine inverse x. This guy will become sine inverse negative 2x under root 1 minus x square. And this interval will become something like this. Right? Now just restructure the whole thing. So this will become pi plus sine inverse 2x under root 1 minus x square. And this is already negative sine inverse x. And this will become x lying between minus 1 to minus 1 by root 2. Because minus x lies between 1 by root 2 to 1 means x should lie between minus 1 to minus 1 by root 2. Just send this negative sign here because I wanted 2 sine inverse x as the subject of the formula. So here one negative sign will come. And here one negative sign will come. Got it? No need to memorize anything. So which one should we consider? What is that question, Lohit? Have I given you some options? I didn't get your question at all. Which one should we consider? It will help me out if you rephrase your question. Oh, sorry, there was a prior message sent by. Okay, sir, 1 by root 2 is included in this interval. Okay, see, when I include one particular number in both the intervals, it doesn't matter whether you are using the top one or the bottom one, the end result is going to be the same. Very simple. Try putting 1 by root 2 in place of x. Okay, what do you get? If I put 1 by root 2 in place of x, this guy is going to give me a pi by 2. Check it out. Sine inverse 2 into 1 by root 2 under root of 1 minus half. This is going to be sine inverse 1, that is pi by 2, right? If you use here also, this will give you pi minus pi by 2, which is pi by 2 anyways. Correct? Similarly, minus 1 by root 2, whether you use over here, whether you use over here, you will end up getting minus pi by 2 in either of the two cases. So you could use anywhere you want, doesn't make any difference to your outcome. Got it? Lohit? Make sense? Any questions? Any questions? Okay. Chalo. The next exercise, you know what I'm going to ask you. What am I going to ask you? Who will tell me what is my next question going to be? No, my next question is going to be sketch y is equal to sine inverse 2x under root 1 minus x square. Okay, let's do that. Let's figure out the graph for this. Very easy. You have to use the redefinition of sine inverse 2x under root 1 minus x square in terms of 2 sine inverse x and get me the graph. Everybody do it. Everybody do it. I want everybody to do it at least once. Just sit down once you're done, okay? Shita is done. Havish done. Pranav done. Vaibhav done. Very good. All right. So rewriting this. So sine inverse of 2x under root 1 minus x square. This is going to be 2 sine inverse x if your x is to lie between minus 1 by root 2 to 1 by root 2. Okay. And it is going to be pi minus 2 sine inverse x if it is to lie between 1 by root 2 to 1. And it is minus pi minus 2 sine inverse x if it is to lie between minus 1 to minus 1 by root 2. Okay. Now I will only draw these two part of the graph. The third one will automatically come because I know this function is a odd function, correct? So let's draw first of all the part which is valid for 1 by root 2 to minus 1 by root 2. This part. In this part, you are going to draw the graph of 2 sine inverse x. Now, sine inverse x, where should I draw it? Yeah, sine inverse x graph, everybody knows it's like this. Okay. And 2 sine inverse x will go from minus pi to pi. Now, what I'm going to do, I'm going to cut this graph between minus 1 by root 2 to 1 by root 2. So, I'll take a scissor, 2 scissors, both the places, right? And I'm going to cut this part and lift it and paste it over here. Okay, now it may have to stretch it a bit because it will look like this. Okay, now see, this guy will end up at, who will tell me where will it end up? At 1 by root 2, 2 sine inverse x will be pi by 2. This will be minus pi by 2. Okay, now I need the part which is from 1 by root 2 onwards, right? And I know for sure it has to be continuous. So it has to start from here onwards, correct? So now I will go back again and I will try to fetch the graph of pi minus 2 sine inverse x. So for that, it's very simple. First of all, negative 2 sine inverse x is the mirror image of this about the y-axis. Sorry, about the x-axis, correct? So negative of this will be appearing like this. Okay. This I have to, this is the graph of negative 2 sine inverse x. Now this I have to kick up by pi. So what I'm going to do, I'm going to kick this up by pi. So when you kick this up by pi, please note, this was at minus pi. So when you kick this up by pi, it will actually become like this. Okay, not very, yeah, something of this nature. Okay, so everything has gone up by pi when you include this pi over here. Now 1 by root 2 will be somewhere over here and 1 is somewhere over here. I need to take a scissor and I need to cut this part of the graph, pick it up just the way Lord Hanuman picked up Kailash Parvat, right? Which Parvat was that? So just pick that up and dump it over it, like this. Okay, so this will be the part which is going to be useful. Okay, so this part I picked up and I just dumped it over here. And as I told you, this function will be symmetric about the origin because it's an odd function. The other part will look like this. Okay, so this is how the graph is going to look like. Okay, now one thing that you should all be observing over here is that there is a cusp getting formed over here. So at these 2 points, the function is not differentiable. Okay, so the function is non-differentiable or not differentiable at 1 by root 2, minus 1 by root 2, and 1 and minus 1 as well, because at 1 and minus 1, if you draw a tangent, it would be of infinite slope. Okay, so it will not be differentiable at those positions as well. Now, don't worry about the differentiability concept because I'm going to take this up in today's session, not today's session maybe, but continuity differentiability session, maybe after 2 classes or so, because continuity itself will take a bit of time. Is this fine? Any questions here? Can we see this graph on GeoGebra? Can we see this graph on GeoGebra? Let's do that. So y is equal to arc sine 2x 1 minus x square to the power of half. There you go. This is how it would look like. I'll paste it over here. Is it okay? Any questions, any concerns? So with this, we now move on. We now move on to the formula of 2 cos inverse x in terms of cos inverse. We will take a collective problem on these concepts little later on after we are done with the theory part. So who will tell me? Property number 11, right? Property number 11 or 12? 11. Yeah. All right. So the next formula that we are going to do is 2 cos inverse x. Now again, this is an opportunity for you to exercise whatever learnings you have done. So tell me what is the thing that I should write over here and what is the interval that I should be using over here, and are there any more subsequent formulas? Are there any more formulas? If yes, what is that? And what is the interval of x that we are going to use? This time I want everybody to get this right. Then we'll take up the graph for whatever we are getting in the question mark place. Think you know everything, don't worry. Very good, Pranav. Very good, Gayatri. Yes, yes, yes. I want the intervals as well. Yeah, I want the interval as well. Okay, Aditya is saying, okay, so many intervals will come. Fine. Okay, Pranav. Yes, others. Arabi, Hariharan, Aditi, Gaurav, Arjun, Charan, Bhumika, Rashmika, Suman. Pradyun. सर जी π/2 पे तो cos इनवर्स बेहोश हो जाएगा. π/2 π/2 is 1.57. Cos inverse cannot operate on such values. So I mean I'm not sure why people are making still mistakes within angle and values. Cos inverse x itself is an angle. X is a value. Again, Arjun also making same mistake. X I want. Maybe you are trying to answer something else, but that is not my requirement. My requirement is what is the formula and for what x. That's my requirement. Yes, I could figure out that you are giving some response for that. But again, convert it to x. You're almost there. Is everybody done at their own end? Yes, yes, I saw your intervals, Pranav. Chalo, we'll discuss it out. See, the first thing is, you know that, let's say this is your angle A, right? So 2A will lie between, now A lies between 0 to pi, so 2A will lie between 0 to 2 pi. Okay. Now the first answer that you have got is basically where your 2A is between, so forget about the answer here. I'm first interested in my interval. Okay. So this is an interval where 2A is between 0 to pi, right? And since there are the interval is 0 to 2 pi, that means pi to 2 pi is still left, which I will probably cover in the next part. First, let us finish this off. So when you say 2a is between 0 to pi, which means a is between 0 to pi by 2, and a is what? A is cos inverse x. So cos inverse x is between 0 to pi by 2. So x is between 0 to 1. Correct? So 0 to 1, 0 to 1, your formula will come out to be, now all of you, what is the answer to this question mark? The answer to this question mark is, what is cos 2a in terms of cos a? This everybody knows. Cos 2a in terms of cos a is 2 cos square a minus 1. Correct? And cos a is x. Right? So this guy question mark will actually be 2x square minus 1. Right? Nothing to remember. Everything will come from your basic trigonometry and of course your interval analysis. Okay. Now, is there any subsequent formula? There has to be, because 0 to 2 pi is not completely exhausted. Right? So 0 to pi I have used out of it. Still pi to 2 pi is left. Right? So I have to take into account where my 2a lies between pi to 2 pi. Okay. Now many of you would have an objection that I'm including pi at both the places. Actually, I know I can use it. That's why I'm using it. But I will justify it after I've done the entire formula. So in this case, your a lies between pi by 2 to pi. So a is nothing but cos inverse x. Correct? So x will be from, tell me, minus 1 to 0. So there will be one more part of the formula which will work when your x is between minus 1 to 0. Got it? Now what will be the outcome out of it? Okay. For that, you have to come back again to this step. Okay. Cos 2a is 2 cos square x minus 1, and you know your 2a will be between pi to 2 pi. Now you are taking cos inverse on both the sides. You tell me, when you take cos inverse of cos 2a, and you know 2a is between pi to 2 pi, what should be the answer that should come out from this operation? You will say, sir, simple. I will call my graph of cos inverse cos theta versus theta, which is actually this. Okay. I will not draw many branches. So pi to 2 pi is this branch. All of you please pay attention. Pi to 2 pi is this branch. I hope you have now known this graph in and out. So this value, this line is y is equal to 2 pi minus x. So here I will get 2 pi minus x. X is 2a. So we have to make 2a the subject of the formula. So 2a will become 2 pi minus cos inverse 2x square minus 1. So the answer here will become 2 pi minus cos inverse 2x square minus 1 for x lying between minus 1 to 0. Is this fine? Any question, any concerns? I did not require any memorization of any stuff. Automatically it came from there. Now some people, they are smart enough. They will say that, oh sir, you want it from minus 1 to 0, which is negative of this. So why didn't you substitute x as minus x in the very first formula? That also is perfectly fine. I don't have to do all those graph and all. Okay. So you know the second interval is the negative of the first interval. So why don't we use the very first formula, change x with minus x, and make cos 2 cos inverse x the subject of the formula from there? That will also give me the result. So many ways, so many ways. You just have to start thinking out of the box. Is it clear? Any questions, any concerns? Okay, don't worry. You have 3 more opportunities. But before that, you know what is going to be my next question? Sketch Madi. Sketch the graph of cos inverse of 2x square minus 1. This is going to be a very simple graph. By the way, this is an even function. So please note, this function is an even function. For your betterment, I will write down this formula again for you. this will be 2 pi minus 2 cos inverse x when x is between minus 1 to 0. Okay. So you don't have to draw both the parts, just draw the first part. The second part will be the mirror image. Done. Very good, Havish. Aditya. Havish, you were absent last class if I'm not mistaken. Okay. All well? I mean, all well on health front? No issues with health and all? Okay, Varjun, Vaibhav. Okay, I hope you watched the recordings. Okay, Chalo, we'll discuss it out. So first part is 0 to 1 part. 0 to 1 part, you are going to make the graph of 2 cos inverse x. Now see, cos inverse x graph itself is this. Okay. 2 cos inverse x is just zoomed up. I mean, zoomed along the y-axis, or you can say stretched along the y-axis. So this guy is going to be pi, this guy is going to be 2 pi. Okay. So you have to draw which part which is between 0 to 1. So basically cut this part. Okay, this part. Lift it up. Okay, like Hanuman, and just put it over here. So this is going to look like this. Ayyo. Okay. By the way, this is slightly skewed because this will be at pi. So this gap is almost 1/3 this gap, but doesn't look like it in the diagram. Okay. Now the second part is just this. Okay. It's like a dome. It's like a dome on the. You can have these kind of domes in religious places. Is this fine? Okay. Now there is a confusion in the minds of the students. Sir, is there any corner getting formed over here, or is it a smooth transition? What do you think? Is it a smooth transition, or there is a corner getting formed over here? What do you think? Yes, it's a corner getting formed over here. Please be careful. That's why this function is not differentiable at 0. Okay, so I'll write that down over here. It's non-differentiable at x equal to 0 and also at x equal to plus or minus 1, because here vertical tangents will get formed. Okay. Okay, we'll see the graph of this on GeoGebra as well. By the way, many of you would be wondering why sir is saying at corners it is not differentiable. I'm basically assuming that you have done a bit of it in your school as well. Does everybody know that if there's a corner in the graph, at that position the graph is not differentiable, right? That everybody, I'm assuming, would have known it. But let's say if you're not aware of it, don't worry. In few days, we are going to talk about that as well. So time to now draw the graph of arc cos 2x square minus 1. Okay. Mostly it is looking like a flame kind of a structure, more of that sort, right? It looks like a flame. Okay. Let me paste it over here. Is this fine? Any questions, any concerns? Good. Can I now move on to the next property, which is property number 12? Any questions? Any questions, any concerns? All right. So property number 12. Now I'm going to start with triple angle properties or triple angle identities. The approach is the same. Please, help me to find out the following property. Now you should be helping me out. I'm not going to, I should not, my contribution should be least in this. So if I want the formula of 3 tan inverse x in terms of tan inverse, okay, what should be this formula be? And what should be the interval of x I should be using? And are there any more formulas for this? Means, are there any more subparts to this? If yes, please go ahead and help me to figure out this complete formula. In fact, I would request you all to say done if you're done on at your end so that I can start the discussion for it. Treat this as question in itself. Let me not dump any properties on you, because if you derive it, you will remember it for a long, long time. Okay, Hariharan. So Hariharan is asking me if I could help him with tan 3a formula. Okay. So tan 3a formula is 3 tan a minus tan cube a by 1 minus 3 tan square a. Correct, Arjun. Our interval of analysis is open interval, not closed. Open interval, whatever you have written. I don't want to spell it out, else people will get an idea. Very good, Pradyun. Absolutely correct. Good. Very good, Arjun. Anybody who is still not able to figure out that how we are, deriving the formula, so easily, please immediately raise the flag so that I can address it. Don't stay with your doubts. Don't stay with your doubts. Don't be like, okay, after the class, probably I'll watch the video n number of times and try to figure it out. Get it clarified here. The main purpose of a live class is live clarification of doubts and participation. Okay, Anusha. Okay, so most of you have given me the right option for this first question mark, but the second question, the 2 question marks over here, that is your interval, some of you are shaky on that front. So it's very obvious that we are looking at 3, let's say I call this angle as A. So we are looking at 3A angle, and basically this is going to cater to, correct me if I'm wrong, open interval minus 3 pi by 2 to 3 pi by 2, right? Okay. Now this actually helps me to break these intervals. So first interval that this will address is when your 3a is between minus pi by 2 to pi by 2. So that part is addressed in the very first arm. We know that for sure, right? What is left? Left is pi by 2 to 3 pi by 2. So that part is left. So that let me write that as well over here. Pi by 2 to 3 pi by 2. See guys, I'm keeping a gap of pi max because these functions change their nature after every pi gap. Okay. And what is left to the left of minus pi by 2 to minus 3 pi by 2, that interval is left. So you will have three formulas coming for sure. Okay. So there was a lot of confusion last year. People used to ask me, sir, I can derive this, values, but I forget whether there are 2 intervals or 3 intervals or 5 intervals or 10 intervals. I forget that. You will not forget that if you start breaking it up into pi gap. Okay. So now, if this is your 3A interval, okay, let's figure out the intervals first. We'll come to the result little later on. If this is 3A interval, that means your A interval is between minus pi by 6 to pi by 6. Correct? And A was your tan inverse x, right? A was your tan inverse x. So you just take tan of these two angles. So if you take tan of these two angles, you'll end up getting minus 1 by root 3 to 1 by root 3. So the first interval that you should be getting is open interval minus 1 by root 3 to 1 by root 3. And well done. Most of you have got it. Good work. You didn't take any of my help for this. Similarly, the second interval would be your A lying between pi by 6 to, now this will become pi by 2. So this will go to 1 by root 3 to infinity. Because tan of pi by 6, 1 by root 3, tan of any angle tending to pi by 2, infinity. Similarly, the last one will become A lying between minus pi by 2 to minus pi by 6. So this will give you x lying between minus infinity to minus 1 by root 3. So I'm basically done with my intervals. I just have to figure out the results. Okay, so how will I figure it out? Let's check that out. Not a difficult one. Okay, I'm just putting a barricade over here so that you don't get confused. Yeah. Now, what is the result going to be? So first of all, the main question mark thing is very evident to all of you from this formula, that the main question mark is actually 3x minus x cubed by 1 minus 3x squared, because ultimately tan of 3a is this expression itself. Tan of 3a is this expression itself. So this question mark is 3x minus x cubed upon 1 minus 3x squared. Okay. Now, let's try to figure out the the subsequent formulas. So now the second formula, if you recall, your 3a was between pi by 2 to 3 pi by 2. Okay. So it was between pi by 2 to 3 pi by 2. So when you take a tan inverse on both the sides, what is the outcome that should come from this operation? What outcome should come? So you'll say, sir, simple. I will refer to my graph of tan inverse tan theta versus theta. I know them properly. This is how the graph looks like. Okay. Now pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2 is basically you are looking at this line. This line equation is y is equal to x minus pi. Correct. So this is going to give you 3a minus pi. Correct. So you are just going to send the pi to the other side and make 3a the subject of the formula, which I'm going to do it in this step only. I don't want to write it again and again. Okay. Another thing is that some of you would have already noticed the pattern also, right? How does tan inverse pattern go? Pi plus, and what should be the next one? So you have to come to the third quadrant. So pi plus and minus pi plus. Absolutely. Okay. So you don't have to, do that step also, which I told you. But in case you don't, if you forget the pattern, then this is how you can actually work this out. Okay. Are you getting my point? Any questions? So nothing to remember. And one more thing you would have observed, that the second property is a negative of the third property. That means x is negative there. So you could have derived the third one from the second one also. So many venues I have opened for you. Use them. Shouldn't be minus pi. Why? No, it can't be minus pi. Minus pi will be in the third one. Check it out, Kshitij, if you have any doubt. देखो common sense भी ये कहता है. See, all of you please pay attention. In this interval 1 by root 3 to infinity, this guy will be from pi by 2 to 3 pi by 2. Correct? If I subtract a pi here, then this will further reduce by minus pi. That minus pi by 2 to pi by 2 will further reduce. I want to increase it, not reduce it. Okay. Okay. Next, the obvious step is sketch the graph. So we'll do that. And we will quickly now move on to the graph. So the question coming from my side is sketch the graph of y is equal to tan inverse 3x minus x cube 3x minus x cube by 1 minus 3x square. Okay, please do this immediately and tell me what is the graph that you see. Just say done once you're done. You may refer to this formula. Oh, okay, Rashmika, no issues. Thank you for letting me know. Which tab are you using? Samsung. Lenovo. Done. Kshitij is done. Okay, cool. So guys, let me tell you here also one very interesting observation. This function which I've asked you to plot, okay, this function is also an odd function. So if you're able to plot the graph, for at least the top two, for at least these two intervals, minus 1 by root 3 to 1 by root 3 and 1 by root 3 to infinity, then the third one will automatically come from the fact that we are dealing with an odd function. Okay. So let us draw the graph for, first of all, minus 1 by root 3 to 1 by root 3. So for this interval, you are aware that this function is going to behave like 3 tan inverse x. So it is the graph of tan inverse x stretched 3 times along the y-axis, right? So that would give me, if I'm not mistaken, a structure like this. Okay. Meanwhile, where will this graph stop? On the top, it has to stop at pi by 2, right? And it has to stop at minus pi by 2. And there will be holes over here because these values are not permissible in the given function, because 1 by root 3 and minus 1 by root 3, as you can see, I have put a round brackets because they cannot be put in this function, because that will create a 0 in the denominator over here. Okay. So this is the graph of the part which is between minus 1 by root 3 to 1 by root 3. Correct. Now, talking about 1 by root 3 to infinity part. For 1 by root 3 to infinity part, I have to draw the graph of 3 tan inverse x minus pi. Okay, so send this pi to the other side because we have to make this as the subject of the formula, right? So send this pi to the other side and ask yourself, 3 tan inverse x minus pi, I want that part of the graph which is from 1 by root 3 to infinity. So let's do that. I will help you to do that. So let's draw the graph of 3 tan inverse x first. So 3 tan inverse x graph will be like this. We know that this is going to be asymptotic to 3 pi by 2 here. This is going to be asymptotic to minus 3 pi by 2 here. Correct? Now what are we doing? We are going to subtract the pi from this graph. That means this graph is going to be pulled down by pi. Right? So you're going to pull this graph down by pi. So can I say that if this graph is pulled down by pi, this arm that you see will basically die like this. Am I right? Okay. So this will be pi by 2 line. Okay. Now I have to cut from 1 by root 3. 1 by root 3 will be somewhere over here. Right? How did I know that 1 by root 3 will be somewhere over here? Is because 3 tan inverse 1 by root 3 minus pi. This value comes out to be 3 into pi by 6 minus pi, which is minus pi by 2. So I should have reached minus pi by 2 by this time. Okay. So this whole part, I'm going to just pick it up and I'm going to dump it in this particular place. Okay. Now, please be careful. It's going to cut past the x-axis this time. Okay. So it is going to be like this. All of you, please pay attention. Yeah. Okay. Please note it is not going to achieve pi by 2. So pi by 2 will be asymptotic. Now, where do you think it is going to cut the x-axis? What value will be there? So obviously you will say, sir, when this graph becomes a 0. Okay. Right. So let's say I call this as an x. When will this become a 0? This will become a 0 when your tan inverse x becomes pi by 3. So x becomes root 3. So at root 3, this function is going to cut past the x-axis. Clear? Any questions, anybody? Any questions? Make sure you're putting holes in the graph wherever the function is not defined or the graph is not defined. Now, since it is an odd function, I don't have to apply my brain in order to draw the part which is to the left of minus 1 by root 3, because I just have to take the mirror image, and the mirror image part will look like this, and correct me if I'm wrong. There you go. Again, this part will be asymptotic to minus pi by 2. Cutting the x-axis again at negative root 3. Is this fine? Any questions, any concerns? Now you can see the function is facing discontinuity. The function is having discontinuity at x is equal to plus minus 1 by root 3. So the function is having discontinuity there, and hence it is non-differentiable also at those points. Okay. Is there any point where the function is facing any kind of a discontinuity or non-differentiability issue other than these two positions? I don't think so. Okay. Yes, all the places it is working fine. Don't worry too much about it. We have a separate session on it. Okay. So this is the graph of this is the graph of tan inverse 3x minus x cubed by 1 minus 3x squared. Let us look at it on GeoGebra also, so that we can know the exact nature of the graph. So y is equal to arctan 3x minus x cubed upon 1 minus 3x squared. There you go. This is how it will appear. Yeah. So let me just copy paste that over here, Murli, towards the corner. Okay. Is it fine? Any questions, any concerns? Do let me know. So let's now move on to subsequent property. Which property was this? Property number 12. Now property number 13. Yo, sir, how many properties? Don't worry, we are now nearing the end of this chapter. Property number 13. Okay. So property number 13, we are going to take 3 sine inverse x formula in terms of sine inverse. So better tell me what is this question mark and what is the interval of x for which it will be valid, and are there any subsequent formulas to this? Okay. It should be now less than a 2-minute exercise for all of you. Please do it at your own end and let me know once you're done. Very good, Avish. Pratik done? Good. Arjun done. Oh, Arjun is basically mentioning the overall thing that we need to consider. Correct, Arjun? Go ahead. Right track. Done. Shit is done. Shreya is done. Okay. Chalo, those who are done, are you seeing this as your answer? Okay, I'll not repeat the whole stuff. Do you see a 3x minus 4x cube coming over here? And half of pi by 2 is pi by 6, sine of that will be minus half to half. Okay, so this will be minus half to half. Are you seeing that? Okay. Yes or no? The next interval that you would be seeing is half to 1. And the next interval that you will be seeing is minus 1 to minus half. Half to 1, do you see pi minus sine inverse 3x minus 4x cube? And for this, do you see minus pi minus sine inverse of 3x minus 4x cube? So this is your complete formula. How many of you got this right completely? Not a single error. Neither in the formula nor in the intervals. Gaurav, very good. Aditya, Gayatri, awesome. Great. Okay. So we will make it slightly faster here. Let's try to graph the function. First, copy this down if you want to. Good. Very good, Charan, Rohit. After this, we'll have one more round. That would be the last round with respect to the application of your trick. So better get it right in the next round, if not in this round. So next round will be the last opportunity for all of you. All right. So next is obviously, you know, what is my next question? sketch the graph of y is equal to sine inverse 3x minus 4x cube. And let me know once you're done with the sketch. Needless to tell, again, this is going to be an odd function yet again. Okay, so this is an odd function. So whatever part you are drawing on one of the quadrants, please take a mirror image of that about the origin. Done, Anusha, very good. By the way, I've just drawn 1/3 of the graph because the function here was just 3 sine inverse x. So minus half to half, you just have to draw the stretched version of 3 sine inverse x between minus half to half. Oh, if you want to go ahead with the 3 cos inverse x, yeah, please go ahead, write it, draw it, and keep it. We'll come to that. You may relax for some time also. All right. Now, the part of the graph which I have to draw, for half to 1. All of you, please pay attention. For half to 1, I have to draw the graph of pi minus 3 sine inverse x. So, minus 3 sine inverse x graph will be like this. Okay. And you just have to, by the way, this guy is going to be at 3 pi by 2. This guy is going to be minus 3 pi by 2. So, this is the graph of negative 3 sine inverse x. Okay. Now I'm going to give it a push of pi. Push of pi means everything will go up by pi. So this graph will be like this. Okay. Now I need that part of the graph which is from half to 1. Okay. So from half to 1. So I have to cut from here this part. Okay. And take it to the other side. By the way, it will start immediately from this position onwards. Okay. And it will go down like this. Okay. So at 1, please note that it would have achieved, at 1 it would have achieved, if you put a 1, it would have achieved minus 3 pi by 2. Sorry, minus pi by 2. So it would have come to the same position, exactly the same position. Okay. Now in between it is going to cut the x-axis somewhere. Where will it cut the x-axis? How do you find that point out? Very simple. You just have to make this guy as a 0. So sine inverse x is going to be pi by 3. That means x is going to be root 3 by 2. So root 3 by 2 position, it will cut the x-axis. Clear? Okay. Now for the part which is to the left of minus 1, you just have to draw the mirror image of this part. Something like this. Okay. So please note, this is also going to cut at negative root 3 by 2. Not very symmetrically made, but I hope you are able to understand. Better to pick it up from the GeoGebra and paste it over here. So let's do that. Y is equal to arc sine 3x minus 4x cubed. There you go. Yeah, this is how the graph will look like. Okay. Now you can see there is no problem with the continuity of the graph, but there are corners at these positions. So at these positions, the function will not be differentiable. Okay. Neither will it be differentiable at 1 and -1 because vertical tangents will get formed at these two positions. Okay. So please note that this function will be non-differentiable at x equal to half, minus half, 1, -1. Because half and minus half, there is a presence of a corner. That means there cannot be a unique tangent drawn at those positions. And 1 and -1, there is a vertical tangent coming up at those two positions. So there cannot be tangents. There cannot be tangents with finite slope drawn at those positions. So non-differentiable at half, minus half, 1 and -1. Any questions here? So with this, we'll now move on to the last part of our chapter, which is probably the last property, property number 14. Okay. Any questions? Do let me know. I'm now going to go to the next slide. Okay. So property number 14. In property number 14, we are now going to discuss 3 cos inverse x formula in terms of cos inverse. So tell me, how many formulas will I have for this and what will be the formula? Please fill in this same set of things that you have done earlier. Done? Awesome. Very good. Very good. Very good. Okay. So this question, since it is the last property, I'll be doing it in a slightly more extensive way so that you are aware of what is going on. So again, let's call this as an angle A. Okay. So A lies between 0 to pi. So 3A will lie between 0 to 3 pi. So 0 to 3 pi, then 3 intervals have to be made because at every interval of pi, things will change. Correct. So this interval will be catering to 0 to pi. There will be one interval which should be catering to pi to 2 pi. And there would be one interval which is catering to 2 pi to 3 pi. Okay. Now, if this is your interval on 3A, A will be from 0 to pi by 3. So x will be from, now just apply cos on both of them. So cos 0 will be 1, cos pi by 3 will be half. Now it is a decreasing function, guys, please note that. So the positions will be switched. Many people, what they do, cos of this they will write here, cos of this they will write over here. In that case, you will end up writing 1 to half. That is not a right way to mention an interval. Interval must always be mentioned from lower value to a higher value, from left to right. Next, this guy says A has to be between pi by 3 to 2 pi by 3. Sorry, pi by 3 to 2 pi by 3. And if you take a cos on both the sides, you will get minus half to half. Okay. This is your A lying between 2 pi by 3 to pi. And if you take cos on both the sides, it will be from -1 to -half. Clear? Okay. So let me write down the intervals here because we have already figured out the intervals. So one is from half to 1. Other is from -half to half. And other is from -1 to -half. Okay, so these are your intervals. I hope nobody has made a mistake with the intros. Clear? Any questions? Okay. Now what will come in this question mark? Simple. You're looking for cos 3a formula in terms of cos A. Cos 3a formula in terms of cos A. What is cos 3a formula in terms of cos A? 4 cos cube A minus 3 cos A. Correct? Which is nothing but 4x cube minus 3x. So this question mark is 4x cube minus 3x. Done. So the first formula is ready in front of us. Is it fine? Any questions with respect to the first one? Okay. Now for the second formula, second and third formula. All of you please pay attention. You are definitely going to use cos inverse 4x cube minus 3x. Okay? Now I will try to solve it in slightly different technique. I know I can use my graph of cos inverse cos theta for it, but all of you please pay attention. You want the answer to be from pi to 2 pi, and this can only give you answer from 0 to pi. What manipulation will you do here? What manipulation will you do over here such that your answer ends up in pi to 2 pi, and whatever you do, it should be such that you lie in the first quadrant or the fourth quadrant. What will you do? Add a pi. See, let me restate what I want to say. I want to do some manipulation with this guy so that I end up getting pi to 2 pi. That is number one. Secondly, whatever I get, if I take cos on that, it should give me this angle itself. That is this value itself, 4x cube minus this. Right, yes. I should do 2 pi minus this. I want to be in the fourth quadrant or the first quadrant. First quadrant mein to ja hi nahi sakte na. I have to come in the fourth quadrant, right? So I have to do 2 pi minus this interval. Then only I will end up getting pi to 2 pi as the answer, right? This is another way to look at it. If you feel you are not fine with this, that means you don't want to apply this, then you can just basically go from your basics. How? Come to this step again. Now you know if your 3a is lying between pi to 2 pi, and I'm taking cos inverse on both the sides. What is the answer that should come from here? Take the help of the graph. The graph says pi to 2 pi. This is the line that you need to be worried about. Okay. This line equation is y is equal to 2 pi minus x. So this will give you 2 pi minus 3a. Okay. Make 3a the subject of the formula. You automatically get 2 pi minus this. Right. So my analysis was a lazy analysis, but if you can do it, you can save time doing all this stuff. So this is how you get it. Okay. Now try this shortcut and tell me. Now this time I have to use the same this guy cos inverse of 4x cube minus 3x. Okay. Now what should I do such that my answer should come between 2 pi to 3 pi, because I know this guy is only between 0 to 2 pi. And whatever I'm going to do, it should either land me in the first quadrant or in the fourth quadrant. That means if I take cos on that, I should get 4x cube minus 3x only. Kya karoge? What will you do? Think. Add a 2 pi. Absolutely. Now you've got a trick. So I don't have to, actually rely on this. Absolutely. Absolutely, Aditya and Kshitij. But let's say if you want to rely on the graph, again come to the same step where you had written cos 3a as 4x cube minus 3x. And now this time your 3a lies between pi to 2 pi. No, sorry, 2 pi to 3 pi. Mistake. Okay. 2 pi to 3 pi is this zone. The equation here is y is equal to x minus 2 pi. So this, if you take cos inverse on both the sides, this output will be x minus 2 pi. Okay, so 3a will become 2 pi plus cos inverse this. That's what I wrote over here. Okay, so this is how you can basically remember all the formulas. I've told you so many techniques to remember it. Whichever technique you are comfortable with, go ahead with it and solve your questions. So we have completed the theory part of it. Maybe we'll take a few problems, 4 or 5 problems we'll take maximum. And then maybe we'll go for a break, and after the break we can start with a new chapter, continuity and differentiability. Please note this down. Anybody who is willing to note this down. Oh, graph. ग्राफ कैसे भूल सकते हैं सर आप? ग्राफ को कैसे आपने भूला दिया? Can you explain the shortcut again? Yeah. What is the shortcut? See, this is 3a, right? And you want your answer to be between 0 to 2 pi. That means whole result should be from pi to 2 pi. Correct? And this guy is from 0 to pi, that I know. So what manipulation will you do using a technique such that, first of all, this entire angle falls either in the first quadrant or in the fourth quadrant. Meanwhile, I just want to say that if you take cos of this whole thing, whatever you have written, okay, it should result into 4x cube minus 3x only, right? So let's say I'm not aware of whatever I'm going to do, but I know that whatever answer comes over here, if I take cos of that, okay, whatever answer comes from here, the cos of that should give me this 4x cube minus this, because cos of 3a should give you the same result as cos of this, right? So using 0 to pi, right, you have to convert pi to 2 pi. So one idea will come in your mind, sir, can I do pi plus this answer? But if you do pi plus this answer, there will be a problem. What problem will happen? Cos pi plus theta is known to give you minus cos theta. But मेरे को minus cos theta नहीं चाहिए, मेरे को cos theta चाहिए. Then what can I do? Then I can do another thing. I can do 2 pi minus theta over here. So what I wrote over here is actually that 2 pi minus theta. Are you getting my point? But if you're not comfortable with this approach, you can always rely on your graph, Ritvik. Okay, so I'm not forcing this on anybody. If you feel you are comfortable with using the graph, get it. No issues. Okay, now my main thing is, now this time I will give you a question of slightly different nature. Sketch this graph. Sketch this graph by using the graph of sine inverse 3x minus 4x cube. So you are already aware of this graph, right? I'll draw it out for you once again. So sine inverse 4x minus x cube graph, we already know the graph looks like this. This will not be that bent also. This will be, yeah, so this will be at 1 and minus 1. So using this graph, that is graph of sine inverse 3x minus 4x cube versus x, can you draw the graph of this function? Can you draw the graph of this function? If yes, how? What all transformations will you use so that you end up getting the graph of sine inverse 3x minus, sorry, you end up getting the graph of cos inverse 4x cube minus 3x from the graph of sine inverse 3x minus 4x cube. Aditya, will you solve everything? Okay, Hariharan, Okay, Aditya. Okay. See, I already know this function. I already know this function, sine inverse 3x minus 4x cube. Okay, let's do the following transformations on this. Number one transformation that I'm going to do is I'm going to take the or let me start with this guy. Okay, I want to get to this graph, right? So what I'm going to do, I'm going to first write it as pi by 2 minus sine inverse of I want this guy. So I'll first write it down like this. Okay, we all know that cos inverse of anything can be written as pi by 2 minus sine inverse of the same thing, correct? Now I'll take a minus out. If I take a minus out, we all know that sine inverse is an odd function, so this will become plus. Okay, so what does it tell you? It just tells you that take this graph, kick it up by pi by 2. You will end up getting the graph of cos inverse 4x cube minus 3x, right? So if you start kicking this graph by pi by 2, this is the graph that you are going to end up getting. Okay, so I'll not draw everything. I'll just draw this graph like this. Okay, this top end will be at pi. This is pi by 2. This position will be minus half. Okay, this positions will be plus half. Right? As you can see, they have change in definition at half, minus half, etc. So this is your final graph. If you just pull this down, it should be at minus 1. This is that. Okay, so we'll see this graph on the GeoGebra tool as well. So let's do this. Y is equal to arc cos four x cube minus 3x. Okay. If I switch on both the graphs, you'll see the shift. Okay, so you'll be able to appreciate the pi by 2 shift. Got it? So that makes your graphing part also slightly easier, right? You don't have to redo the whole stuff again as what we did for the previous ones. So guys, have these kind of observations. Okay, so this is what will make you different from other aspirants. If you're not observant, if you're not analyzing things around you, just following the conventional way of learning, then you will be definitely doing well in JEE main exam, but JEE advanced and KVPY stuff will become slightly dicey. So let me just post this over here. Okay, so now I think we can take up questions. Let's take questions based on whatever we have done today. And then we'll move on to the new chapter. Okay, so let's start with, did we do this question the other day? Have we done this question? Please confirm. Okay. All right. What is the relationship between 3 sine inverse x, 3 cos inverse x, and 3 tan inverse x graphs? See, at least you know the relationship between 3 sine inverse x and 3 cos inverse x graph, because you know the relationship between your sine inverse and cos inverse itself. But with respect to tan inverse, it is difficult to connect them. Tan inverse has a different way of behaving. So if you know 3 sine inverse x graph, you can find the graph of 3 cos inverse x, because you know sine inverse x is pi by 2 minus cos inverse. So it's the case of shifting up and down, or maybe the reflection about the x-axis or y-axis. So that relation I can easily find out, but there is no relation, I guess, between 3 cos inverse and 3 tan inverse directly. Are you getting it, Arjun? Okay. So you can answer that question yourself. The relationship between the graphs will be reflected by the actual relationship between the functions. Correct. For example, 3 sine inverse x is 3 pi by 2 minus 3 cos inverse x, isn't it? So you make the graph of 3 cos inverse x, reflect it about the x-axis, kick it up by 3 pi by 2. You get the answer for 3 sine inverse x. Isn't it? Basic graphs and its transformation. If anybody wants to revise basic graphs and its transformations, do ping me. I will send you the recordings of the last year bridge course session. Okay. Yes. Should I put the poll for this? I'll put the poll, but if you want to reply on the chat box, you can do so. F of x given, g of x is given, and they're asking you which of the following is the value of f10 minus g100. All the options have been touched upon by you. Almost 2 minutes over. I'll give you 1 more minute. Okay, Aditya. Last 15 seconds. Last 15 seconds. 5, 4, 3, 2, 1, go. Okay. So as I've already told you, 3.5 minutes is like, the optimum time to solve a question. So let's see the result. Most of you say option number A, and then some of you have said option number C as well. So A and C share the maximum number of votes between them. Let's try to figure it out. Now, if you look at the question is basically asking you some value in terms of tan inverse. Correct? Look at the options. Okay, so don't have a blind eye towards the options, which most of you are still following, not looking at the options at all while solving questions. No, that's a very, very wrong approach when it comes to solving competitive level exam questions. Okay. So now, if you see, basically we have been using sine inverse 2x by 1 plus x square and cos inverse of x square minus 1 by x square plus 1. Now, this is slightly dicey. This is not in the same format as it should be. Okay. If you recall your formulas, this figure seems to be slightly skewed. Okay. So in short, I need to write down the formula of 2 tan inverse x in terms of sine inverse and cos inverse, right? Now, I'm just going to write down the part which is going to be of relevance to me. Now, since I'm finding f10, that means my x is 10. What is the formula that I'm going to use? I'm going to use the formula of, correct me if I'm wrong, the formula that will be valid will be pi plus sine inverse of, pi minus sine inverse of 2x by 1 plus x square, because this formula is valid for x greater than equal to 1. Am I right? And my x is 10. That's why, since my x is 10, that is why I am basically referring to this formula. Yes or no? Any questions here? Okay. So my f10 value, I should have made us shorter here. I should not have written anything here, by the way. It's a single formula which I want to write. So this is my fx, right? So my f10 value would have been, correct me if I'm wrong, it's pi minus 2 tan inverse 10. So this is one thing that I require in my problem, right? Next is gx. Gx is, correct me if I'm wrong, it is pi minus cos inverse 1 minus x square by 1 plus x square. If I take the minus sign common from the numerator, this is what I should be getting. Correct? And we have already seen that 2 tan inverse x. Okay, this formula is cos inverse 1 minus x square by 1 plus x square if x is positive. Yes or no? Right? And minus of this when x is negative, which I don't need because I only need one formula, because my x here that they're trying to put is 100. Okay. So if I'm not mistaken, then can I say 2 tan inverse 100 is nothing but cos inverse, or you can write it like this. You can write it as pi minus g of 100. Okay. So this guy is pi minus g of 100. Okay. So g of 100 is nothing but pi minus 2 tan inverse 100. Correct. Now what are we looking for? We are looking for f10 minus g100. So now we have these two gentlemen. We have to put one against the other. Ayyo. Yeah. So f10 minus g100 will be nothing but pi minus 2 tan inverse 10 minus pi plus 2 tan inverse 100. Pi goes for a toss. You'll end up getting twice of tan inverse 100 minus tan inverse 10. Is there any option which speaks of this? No, the first one cannot be, second one cannot be, yes, third one is the option. Option C is the right option. And most janta went for option A. Okay. What is this? I didn't get you. That I already accounted for, no? The g of x is this, no? G of x is pi minus this guy. Correct, no? So cos inverse this guy is pi minus g100. So pi minus g100 will be equal to 2 tan inverse x. 2 tan inverse 100. Okay. Be careful. I mean, don't take things for granted. Okay. They may change. They may play with the signs. Okay. So okay. Let's take this one. If x is between -1 to -1 by root 2, then the inverse of this function is which of the following? Let me put the poll on. Guys, let me tell you, only in that part the inverse will exist. I hope you are aware why. Okay, let's do one thing for, yeah, thanks for pointing that out. Let's exclude the minus sign from here. Now is it fine? So assume that D doesn't have a minus sign here. Uh, 2.5 minutes gone, 7 responses so far. Okay, Vaibhav. I can give you 1 more minute, max to max. This is not worth more than 30 seconds ideally. Okay, last 15 seconds. 5, 4, 3, 2, 1, go. Okay, so out of 21 of you who voted, maximum people went for option number A. Few went for C. B and D got lesser votes. Let's check. See, we have already figured out that 2 sine inverse x. Okay, let's write down the formula of 2 sine inverse x. Now, just in this interval, if you recall, in this interval, that is your x lying between -1 to minus 1 by root 2, the formula actually became minus pi minus sine inverse 2x under root 1 minus x squared. Okay, so from there, if I make sine inverse 2x under root 1 minus x squared the subject of the formula, we were basically going to get this guy. Okay, so this is your y. Okay, now whenever we want to find the inverse of any function, what do we normally do? We switch the position of x and y and try to find y from there. Correct? So we normally switch the position of x and y, and I want to find out what is y in terms of x. Okay, so that will give me minus sine inverse y. Yeah, minus 2 sine inverse y is going to be pi plus x. So sine inverse y is going to be uh, minus pi by 2 minus x by 2. So y is going to be sine of this. Okay, what is sine of this? Sine of this is simply going to be minus cos x by 2. So this guy is going to be your inverse of this function. By the way, this question setter has done a stupidity. He has given the answer in terms of y. Ideally, inverse of a function should be in terms of x only. So assuming that he meant this answer, option number A is correct. Okay. So when we write inverse of a function, we write it in terms of x only. Yeah, he has replaced x with y ideally, right? So minus cos x by 2 is your inverse of that function. Okay. So this answers Aditya's question, who asked that what is the inverse of that whole thing? The inverse of the whole thing doesn't exist in one go. It exists in silos. So wherever the function is 1, 1, in that part only the inverse is found out. Okay, Aditya, so I picked up this question because I wanted to convey that message to you. Could you move down? Sure. Is it fine, Shreyas, Rohit? Any questions, any concerns? We'll take few more questions. I know you would be all feeling hungry because I want to wrap this up before we take a break. On the other side of the break, I want to start with a fresh chapter. So we'll take few more questions. Please bear with your hunger for some more time. Can I go to the next page? Rohit and Shreyas, done. Shreyas also done. Next question. I think you should be able to do this. Let's do this one. If x is greater than 1 and cos inverse of x square minus 1 by x square plus 1 plus tan inverse of 2x by x square minus 1 is 2 pi by 3, then which of the following is your x? This time I would request you to give me a response on the chat box, because some of you are not clicking on the chat box and the poll. So please give me a response on the chat box. Okay, Kshitish. Some of you may be trying to scam it out also. That's fine. There are just 4 values to check against. Maybe you will try your luck finding for each one of them. Scam is fastest. Yeah, but as I told you, don't use scam for, during your practice. When you're practicing your papers, assignments, like a test, do it in the most weirdest fashion you can. I mean, don't do it in a shortcut way. Shortcut way is definitely you will be using it during your actual exams. Come on tests you can use, but while practicing your DPPs, don't use shortcuts, because that will kill the concept inside you. You'll rely only on scamming them. You'll think I'm invincible. I can solve all questions by scamming, or most of the questions by scamming. That may backfire. That may work against you at times. Very good, Aritra, Ritvik, Gayatri. Pranav, Gurman, very good. Suman, Aditya. Okay, can I give 1 more minute for the people who are trying hard? Okay, 1 more minute. Please try to finish it off. Nothing very difficult about it. This actually has made your life very easy. This information has made your life actually very, very easy. If that information was not there, that would lead to cases then. Okay, we'll discuss about that shortly. Okay, Vaibhav. Arjun. Okay, good. So I can see one of the options being given by most of you except for one person. So we'll discuss that out. So firstly, if your x is more than 1, let us write down 2 tan inverse x formula in terms of tan inverse and in terms of cos inverse. Okay. Now in terms of cos inverse, it's 1 minus x square by 1 plus x square when x is more than 0. Correct? And it is 2x by 1 minus x square if it is, it is pi plus if it is more than 1. Correct? So pi plus tan inverse 2x by 1 minus x square if it is more than 1. Yes or no? Now let us figure out what are these terms actually. This term is nothing but it's pi minus cos inverse 1 minus x square by 1 plus x square. And this fellow is negative of tan inverse of 2x by 1 minus x square. Be careful. They are trying to deceive you by changing the position of the terms over here. Okay, don't get deceived. And now, can I write this guy as 2 tan inverse x, because this will match with 2 tan inverse x for x greater than 1. So x greater than 1 and x greater than 0, they will follow the same definition. Minus, now here it will follow this minus pi. So 2 tan inverse x minus pi. Okay, this is given to you in the question as 2 pi by 3. So solving this, if I'm not mistaken, it will give you 2 pi minus 4 tan inverse x as 2 pi by 3. So 4 tan inverse x is going to be 2 pi minus 2 pi by 3, which is actually 4 pi by 3. 4 goes for a toss. So x will be tan of pi by 3. Tan of pi by 3 is root 3. So option number B is correct. Okay. Be careful. Now, many people say, sir, if this was not given to us, and let's say this question was an open-ended question, find the number of solutions. How will you solve this? Because you can't take cos on both the sides or tan on both the sides because they're both different trigonometric ratios. Okay. So in that case, you will have to take intervals. How will you take intervals? Now, let me show you that also. This guy works in two intervals, x greater than 0 and x less than or equal to 0, right? Correct. And this guy works in three intervals. One is more than 1. Okay. Other is between -1 to 1. And one is less than -1, right? Correct. Now you have to take these intervals, and in their overlapping, you have to redefine both the functions in terms of tan inverse. Right? So you have to take the overlapping intervals. So let me just show you on the number line. Okay. The first guy, okay, so there is a different set of property for this guy. Okay, so x greater than 1. X greater than 1 will be, I'm so sorry. I wanted to make a 0 here. So not. Yeah, x greater than 1 basically is this zone. And x greater than or equal to 0 for the other party will be this zone. Okay, so from 1 onwards, okay, 1 to infinity, you are going to follow the definition. You are going to follow this definition and the definition of, see, you are going to write tan inverse 2x by 1 minus x square in terms of 2 tan inverse x minus pi, and this has 2 tan inverse x, and solve the question. In your interval -1 to 1, in your interval -1, so this is one overlap that will happen. The other overlap, I'll just write it down over here. Yeah. So see the number of overlaps happening. So this these lines color show that they are behaving differently in these intervals. So let me change the line color. Let me make this as green, and let me make this as probably red. Something like this. Okay. Now all of you please pay attention. In this zone, the behavior of both the functions will be different. In this zone, the behavior will be different. In this zone, the behavior will be different, and in this zone, the behavior will be different. Okay, so you will have 4 conditions coming up. So this will be 4 cases coming up in this question. One will be from -infinity to -1. In that, you have to redefine both the functions in terms of 2 tan inverse. That you know how to do it. You already have the formulas with you. In -1 to 0, you have to redefine the function. In 0 to 1, you have to redefine both the functions. In 1 to infinity, you have to redefine both the functions. So these two guys that you see on your screen, these two gentlemen, they will be redefined for these 4 cases. Now, when you take a case, let's say you take this as your case number 1. This is your case number 1. In this case, you solve the equation, and the answer that you get must be taken intersection with this case, because your answer cannot exceed the parent condition. This is the parent condition. Are you getting what I'm trying to say? Okay. Are you getting what I'm trying to say? So whatever answer you're getting after solving this, you have to take an overlap with this condition. That means x less than -1. Similarly, case 2 that you are taking, whatever you are getting the solution, you have to take an overlap. If let's say the solution doesn't comply to this region, you have to reject that solution. Are you getting it? So third condition also, whatever solution you are getting, you have to take the overlap with the third condition. And fourth condition also, whatever you are getting, you have to take the overlap with the fourth situation, and then you have to finally union all your answers. You have to finally union your answers. Are you getting my point? Let's take a small question on this, and then we can disperse for a break. Just one question we'll take. The last question maybe for the day. I think it was. Yeah, let's take this one. I hope the question is visible to everybody. Let's try to solve this question. We have three different functions involved over here. One is sine inverse, cos inverse, tan inverse, and you're trying to solve for x. Okay, let's do this question, and after this we can take a break. In the initially itself, you have to reject x cannot be 1. Okay, because this guy will become unhappy because of that. No solution can be beyond the domain of the functions involved. Okay, so please, that is the basic thing you should check. My answer should not make a function undefined. If you have found solutions, you can tell me on the chat box. Very good, Gayatri. Shreyas K, very good. Okay, Havish. Very good, Anusha. That's a very weird answer, Havish, but okay, fine. We'll discuss it out. We'll discuss it out. Yes, so if you recall the regions in which these functions used to work, there used to be -1, 0, and 1 as usual, as we have discussed. Okay, so this cos fellow, it behaves differently. And of course, 1 and -1 will not be included. So I'm sorry, I have to exclude both of them. So I have to put holes over here. Okay, so this guy behaves differently in this zone. Maybe I'll use a yellow zone. So this yellow shows how cos behaves. Okay, I'm so sorry. Yeah, so this zone, it changes definition. Tan inverse and sine inverse, these two guys more or less have the same intervals, right? So don't have to worry much about. So I can basically use these colors. Maybe I'll need a pink. Okay. Pink is difficult to see, right? I'll put a maybe a green color. Okay. Now let's try to solve this question. So we have got these zones, less than -1 zone. First of all, x is less than -1. Okay. When x is less than -1, what answer does sine inverse 2x by 1 plus x squared give you in terms of tan inverse? So let's try to write that down. So we have already known that 2 tan inverse x, this answer is going to be minus pi minus sine inverse of 2x by 1 plus x squared if your x is less than equal to, or if your x is between minus infinity to -1. Am I right? Yeah. So can I write it as minus pi minus 2 tan inverse x? So this will be minus pi minus 2 tan inverse x. Okay. Now what about this guy? -4 cos inverse, this fellow will behave as -2 tan inverse x, because for x less than -1 it's negative, so it will become -2 tan inverse x. Okay. And this fellow will behave as, correct me if I'm wrong, it will behave as it has to come in the third quadrant, so it cannot be pi, it will be minus pi plus. So yeah, so it will be 2 tan inverse x will be minus pi plus tan inverse 2x by 1 minus x square when x is less than, or when x belongs to the interval minus infinity to -1. Okay, so this will be 2 tan inverse x plus a pi. So you are solving this equation. Now, if I open this expression up, I'll end up getting -3 pi minus 6 tan inverse x. This will be plus 8 tan inverse x. And this will be 4 tan inverse x plus 2 pi. This is equal to pi by 3. So on solving this, this gives us, if I'm not mistaken, 6 tan inverse x, right? Correct? And these terms will be cancelling out to give you a minus pi. Okay, so this is the equation that you are trying to solve. So 6 tan inverse x is going to give you 4 pi by 3. In other words, tan inverse x is going to give you 4 pi by 18. That's actually 2 pi by 9. Am I right? Have I missed out anything? Okay. But if you see, x is tan of 2 pi by 9 is definitely a positive angle, right? Which is not in compliance. It is not in compliance with x less than -1. So this is rejected. This cannot be my answer. Yes or no? Sorry? Aditya was saying something. -2 pi. Why? Right? Because I want to make tan inverse 1 minus x square the subject of the formula. So this pi will go on the other side, isn't it? Aditya? Yeah. Okay. Next interval that we are going to entertain is between -1 to 0. This is another overlap I can see. Okay. So between -1 to 0, let's try to rephrase this entire event. -1 to 0. Let me just copy this question again because I want to use it. Yeah. So now when it is between -1 to 0, Okay, I'll not expand it a lot. So how are these guys going to behave between -1 to 0? So -1 to 0, how will this guy behave? Now, sine inverse, 2 tan inverse x, when it is between -1 to 1, it behaves as 2 tan inverse x itself. So this will be blatantly following the 2 tan inverse x formula. Correct? Yes or no? Any questions here? And what about this guy? This guy is going to still follow -2 tan inverse x. Correct? And this guy is going to again follow the same 2 tan inverse x formula. Okay, and on simplification, what I'm going to see, 6 plus 8 plus 4. So 6 plus 8 plus 4, that's going to be almost 18, right? Okay. Okay. Now this also is not going to meet my criteria, because when I solve this, I'm going to get tan as x as tan of pi by 54. Now pi by 54 happens to be in the first quadrant. So this has to be a positive answer, which is not, so this also is rejected. Okay, because it is not complying with my parent condition. My parent condition is only valid for between -1 to 0. So I should be getting at least a negative answer. Got it? Now I will take up the third interval, which is between 0 to 1, which is this guy. Between 0 to 1 is this guy. Between 0 to 1, the definition will be more or less the same. Let's try to figure it out. Between 0 to 1, this guy will give me again 2 tan inverse x. But this guy is going to give me just 2 tan inverse x. Okay. And this is again 2 times 2 tan inverse x is equal to pi by 3. So 4 plus 6, 10. 10 minus 8 is 2. So 2 tan inverse x is pi by 3. So tan inverse x is pi by 6. So x is going to be, x is going to be 1 upon root 3. 1 upon root 3 meets this criteria. So this is accepted. This could be a solution. Okay. So many of you have also said 1 by root 3 as a solution. That is absolutely accepted. Is there any more solutions? Let's try to figure it out. Now the only part left is when your x is more than 1. Okay. So when x is more than 1, I'm going to do it on the top part over here. So how would these guys change? So sine inverse of 2x by 1 plus x square, when x is more than 1, it's going to give you, let me recollect, it's going to give you 2 tan inverse x is going to give you pi minus theta. So it's going to give you pi minus 2 tan inverse x. So thrice of that, isn't it? Correct? And this guy is going to give you 4 into 2 tan inverse x, the second guy. And the third guy, when x is more than 1, it gives you pi plus, correct? So pi plus means 2 tan inverse x minus pi. So it is going to give you 2 tan inverse x minus pi. So that's going to give you pi by 3. Okay, let's try to solve it. So if I just simplify it, 3 pi and minus 2 pi will give you a pi. And you have minus 6 minus 8, which is minus 14. Minus 14 plus 4 is minus 10. Okay. So this gives you, if I'm not mistaken, tan inverse x as 2 pi by 30. Okay. That is pi by 15. Pi by 15. Now x is tan pi by 15. This is going to be rejected again, because x cannot be, this value is not more than 1, because pi by 15 is even less than pi by 4. So the answer has to be less than 1. It can't be more than 1. So this is also rejected. This is also rejected. So there is only one answer possible, which is nothing but 1 by root 3, which all of you gave me the answer, which is this guy. So this is the only answer possible. So answer is going to be 1 by root 3. Now, as I told you, if the interval is given, it makes your life easy. If not, you have to take cases. So with this, we will conclude this chapter of inverse trigonometry. This was a good chapter for us. We will take a break right now. The time as per my watch is 6:32, but I will consider it to be 6:33. Let's meet at exactly 6:48 p.m. On the other side of the break, I will start with continuity and differentiability.